Hi ladies and gentlemen, this is Ms. Skokin. We're back to talk about Algebra 2 Honors. This is section 6.5, Operations with Functions. We are going to start with a warm-up, and you have some polynomial functions to perform. I'm going to ask you to turn the video off, work on these problems, and then turn the video back on when you're ready to check your answers. Okay, hopefully you were able to successfully subtract these two polynomials and multiply these. Remember, order of operations, you have to simplify the power first, the power on the binomial, and last of all we had division. It looks like a fraction, but we know that that fraction bar means division, so we have options with division. In this case, the most expedient way to deal with this one is to factor and then simplify. So let's talk about our objectives. We're going to add, subtract, multiply, and divide functions. You saw a little bit of a preview with our warm-up. And then we're going to write and evaluate composite functions. This is something new that we haven't seen before, and therefore we have a new vocabulary word, composition of functions. So that's what this new operation is that we're going to discuss. We know that we can perform operations on functions in a similar way to performing them on numbers or on expressions. We can add, subtract, multiply, or divide functions by operating on their function rules. So if we are trying to add two functions, f and g, and create a brand new function, f plus g of x, then we get f plus g of x by adding the original functions f of x and g of x. When it comes to subtraction, it's very similar. We have a new function that we want to create, f minus g of x, and we do that by subtracting f of x minus g of x. For multiplication, notice the way that we write this. The notation is that we put the f and g next to each other, so it's f times g of x, and that is how we write when we want to multiply these two functions. Another way that we could write it, if you see the right hand side of that equation, it says f of x times g of x. So either one of those ways is appropriate to write. The new function that we create by multiplying though is the f times g of x. And when we want to create a new function through division, f over g of x, we're going to be able to find it by dividing f of x divided by g of x. And we just need to specify the excluded value. We can't have division by 0, so g of x is not allowed to be equal to 0. Let's take a look at an example of adding two functions, and you can see we want to create a new function f plus g of x, and we're given f of x and g of x. Again, I'm going to ask you to turn off the video and turn it back on when you're ready to check your answer. This one was not very difficult. One of the things that you may want to do is set your addition up in columns so that you are adding like terms in columns, similar to the way that we learned to do addition back in, I want to say maybe it was second grade. We used columns to indicate place value, and that really works well with the like term. So all of the x squared terms in one column, all of the x terms in one column, and all of the constant terms. And that will work regardless of how many different terms you have and how many different types of terms you have. All right, let's take a look at B. We're using the same two functions, but this time we're subtracting. So once again, turn the video back on when you are ready to check your answer of this subtraction. If you had any difficulty or have a question on any of the questions on example 1, put a post-it note in your notes or make a notation in your notes so that we can go over it in class. Although we already talked about the rational functions chapter, this is just a little reminder. When we divide functions, we need to make sure that we make a notation about any domain restrictions, and that means if we have a value of x that's not going to work because it ends up in the denominator and causes division by 0, we need to make a note of it. In example 2, we're multiplying and dividing functions. We have been given functions f of x and g of x, and we want to create a new function f times g of x. So we can multiply functions in a few different ways. One of the ways may be the matrix, and if you remember, we put the terms across the top of one function and down the side of the second function. It's very convenient for us to do that because it makes it easy for not only the multiplication piece, but then combining like terms. But either way, you have choices. So once again, turn the video off, multiply f of x and g of x to one another, and then turn the video back on to check your answer. If you weren't exactly sure where to start or had any difficulty, pause the video so that you can copy this down into your notes and make sure you're able to follow the work successfully. We're going to take a look now at division. And we're using the same two functions that we had a minute ago, but this time we're going to find a new function, f over g of x. And that means we're dividing. Now remember, you have options when you're trying to divide, but our go-to option is to factor and then see if things cancel out. If you need a review of factoring because you have any trouble with this factoring, again, make a notation in your notes and try to work this one out. Make sure you do GCFs first and then use the rainbow rule. And if you have any questions about this, let's either go over it in extra help or in class. Our final answer to our new function f over g of x is 3x plus 4, and the excluded value is 3 over 2, and that was because of the whole that we ended up finding when we factored. We're going to introduce another type of operation now, and it's called composition of functions. And what it does is it takes the output of one function and uses it as the input to the next function. So it's kind of like a series of functions in a row. And again, it's called composition of functions. So the symbol that we use, the notation that we use is f, and you see that little circle, g, and we read that f composition g of x. And the definition of it, or the way that we determine what it's equal to, is f of g of x. So what this means is we take g of x and we use it as an input to the function f of x. This is one of those things that is easier to explain when you see how it works and harder to understand when you're just getting a description. So let's take a look and see how it works. So imagine that we have f composition g that we want to find. And we know that that means f of g of x. Well, g of x is on the inside of the parentheses of f of x, so that means that following order of operations, we start on the inside and work our way outward. So that means we're going to do g of x first. In this case, we have a function that when 1 is the input, this is function g, 4 is the output. And we take that 4, that's the output of g, and we input it into function f, and the output of function f is 8. So that means f of g of 1 is going to be equal to 8. The order of operations means you have to do the one that's on the inside first. So if it's f composition g, then g is on the inside. If we see it reversed, then we need to do it in the reverse order. So pay attention to which one comes first and which one comes second in order and exactly how it's written. And here's a little caution. Just remember that when we multiply functions, we don't write it like when we write composition of functions. Multiplying functions, we're either going to write f times g of x, or it's going to be f of x times g of x. When it comes to composition, it's going to look like one of the functions is input to the other function. So you can see g of x is inside the argument for f. All right, let's take a look at example 3. What we're going to do is start out with two functions, f of x and g of x, and we're going to first find f of g of 4. That means we're going to take 4 as the input to function g, and whatever we get as a result of function g, we're going to input that into function f. So g of 4 means we input 4 into function g. When we input 4, it's 7 minus 4, and we get 3. We're going to take that 3, and we're going to insert it into function f. That means 2 to the third power, which is 8. So f of g of 4 is 8. All right, let's take a look at another example. And we're going to use the same two functions, but we're going to do them in the reverse order. So g of f of 4 means we're starting out by evaluating f of 4 first. And of course, 2 to the fourth power gives us 16. We're going to take 16 and insert it into g. So g of 16 is 7 minus 16, giving us negative 9. Pay close attention to the fact that we ended up with two different values when we had f of g and when we had g of f. So we're not always going to get two different values, but most of the time we are. And we'll talk about when we don't get two different values in a couple sections from now. Sometimes we don't have a specific number to input, and what we want to do is just input the whole function into the other function and then simplify. And we do that to create a new function rule, and then we can use it for any input that we have. So let's take a look at what that looks like. Here in example number 4, we have a function f of x and another function g of x. We want to write the composition function f of g of x. That means we're going to take g of x, and every time we see an x in f of x, we're going to insert the right-hand side of g of x. And you can see what we're doing is f of, and then the input to f is going to be g of x, x over 1 minus x. And we insert that into function f, which is input squared or x squared minus 1. And then we just simplify. So once we're able to simplify, we come up with the final definition of the new function f of g of x. And of course, we need to list excluded values. So when we list the domain, we need to make sure to exclude 1 because it would cause division by 0. For example 4b, we're using the same two functions, but we're going to reverse the order. So we're going to find g of f of x. This one is not hard. You follow the same steps and turn the video back on after you give this one a try. Okay, so the first thing we need to do is expand that we're finding g of f of x. So f of x is the input to function g. So f of x is equal to x squared minus 1. We input that into function g, which means every time we see an x, and you can see it's x over 1 minus x, every time we see an x, we're actually going to input in that spot x squared minus 1, which is function f. Once we do that, we simplify what we have and then determine if there are any excluded values for our new function. And you can see that if we have plus or minus square root 2 in the denominator, we would end up with division by 0, so we have to exclude those values. Composition of functions is not something that's difficult, but it is something that takes some practice to get used to. It feels like there's a lot of variables and a lot of notation that makes it confusing, but the more that you practice this, the easier it gets. Last of all, we have a word problem that we're going to be using, and just a little reminder here, composite functions can be used to simplify a series of functions, and a lot of word problems end up looking like that. So we have an example. Jake imports furniture from Mexico. There's an exchange rate of 11.3 pesos per US dollar. The cost of each piece of furniture is given in pesos, so that means we're going to need to convert into dollars. And in addition to that, the total cost of each piece of furniture includes a 15% service charge. So the first thing that we want to do is write a composite function to represent the total cost of a piece of furniture in dollars if the item starts out as C pesos. So remember, we want to convert it to dollars, and then we're going to be including the service charge. So in order to convert the pesos to US dollars, we're going to divide by 11.3. So we're going to take the cost and divide by 11.3. The other thing that needs to happen is we need to add 15% to the cost so that that would represent the service charge. So it's going to be multiplied by 1.15. So when we look at the full composite function, it is going to be 1.15 times C over 11 pesos 30. All right, so we've got the rule now for our new function d of p of c, and the next thing that we're going to do is input to that the cost of a table that's 1,800 pesos. So we use our composite function, and we end up with $183.19. That does it for section 6.5, and I'll see you back for section 6.6.